EAP support teacher.
No.
Who?
No.
Why was the class late today? Like, you're not usually late for this class. Is today a different timetable?
No. Yesterday you sent an email to us. Our EAP support will start at 12 o'clock.
Okay. Transformers. Ready, go?
Yeah.
Why were you at home?
So,
Okay. Yeah. So, describe a simple. So this lesson is quite easy. We'll get 2 lessons done for sure today. Right, in this lecture we will study transformers. So we're going to study transformers. Yeah. You know this one?
Yeah.
Who is he?
请看住.
No, in English.
Megatron.
No, that's not Megatron.
Optimus Prime.
Optimus Prime. Yeah. No, we're not studying that. This is what transformers look like in physics. Yeah, they're not as exciting. Not as exciting. This is a transformer. So I'll explain it here with a picture. We'll draw the picture first. So for a transformer, what you need, a couple of things. You need what's called an iron core. That's this thing here. And then this side is called the primary, and this side is called the secondary. Primary coil, secondary coil. And here you have a COIL.
Oh, iron core.
Yeah. And here you have
It's L?
oh my goodness,
Iron.
COIL.
That is RE.
COIL.
In the top.
Huh?
The
Oh.
top one.
Iron core, CORE. Yeah? Okay. So this is an alternating current, AC, and we say it has voltage 1. Then what you do is you have a wire here. This is also an alternating current. And this has voltage V2. Now, this guy here is wrapped around N1 times, and this one here is N2 times, and they are different numbers. So what you can do with a transformer is you can take this as an input, and you can get a different voltage out. It changes the voltage. Now, how does this work? We'll explain now. So what's the idea behind this? So do you remember you have your right-hand grip rule? Right-hand grip rule. So when you have a current, you have a magnetic field. Okay. So what you get here is, yeah, okay. You get a magnetic field around here. This is a B. Okay. It's okay. It's going around this way, right? Now, because this is an alternating current, it means it changes direction. Okay, so this B goes plus, minus, plus, minus, plus. It keeps changing. Okay, so this means you have a delta B. Okay, now the area here doesn't change. So you have this times this is equal to this. Yeah? And you can divide by delta t. So in other words, what I'm trying to say is, because you have this, then remember we said this is equal to EMF, a voltage. Yeah? Yeah. Now, there's one thing I forgot actually here. Because this is wrapped N1 times, I need to have an N1 here. So there's an N1 here. Okay? And this is this here is going to be E2, or V2 rather. Because what happens is, this causes a voltage here. Do you see? You remember, if we move our magnet, we can make a current. Okay? So if we move the magnetic field here, we can make a current here. So anyways, on the left we have V2 equals N1 delta phi over delta t. You can do the same thing here, and you'll get V1 equals N2 delta phi over delta t. Now, I suppose really I should have minus and minus here, but it's not a big deal. So if I put these together, I can say V2 over N1 equals N2 over V1. True? No, false. V1 over N2. I made a mistake. No, sorry. Sorry.
What?
I made a small mistake in this one. I used V2 because it's the current here. So I should have used N2 here because it's the number of turns here.
Oh.
Yeah, not in this one. So that should have been an N2, and that should be an N1. So that should be an N2, and that should be an N1. So that means we get the final result here. N1 over N2 equals V1 over V2. That's the end. That's the result here. This is our formula. So do you see what's happening? If you have more turns here and less turns here, what happens to the voltage? Do you have more or less voltage? V2. Is it bigger or smaller?
Smaller.
Smaller. And if these are small and this side is big, then the V2 becomes bigger. So you can use this to change voltage. You can make it increase the voltage, or you can make it decrease the voltage. So your V1 can turn into a bigger V2, or your V1 can turn into a smaller V2. You can make it go up or down. Okay, so for example here, this is a transformer here. It takes 220 and changes it into 19.5. Okay? Sometimes you need the opposite. Sometimes you need a small voltage and to make it into a big voltage. You can go either way. Okay? So, what's the definition of a transformer? A transformer is an electrical device that transfers electrical energy between two or more circuits through induction. Electromagnetic induction produces an EMF. Commonly, transformers are used to increase or decrease voltages. Okay. So, wait. You don't have to write all of this. I'll tell you what you need for the exam. Okay. So the two most important things to write is transformers are used to increase or decrease the voltage of alternating current in electric power supply. And then at the end you can just write by using electromagnetic induction, the thing we did last time. Okay, so you can just say transformers are used to increase or decrease the voltage of alternating currents in electric power applications by using electromagnetic induction. Got that? Yeah. Yeah? Ben? By using electromagnetic induction. Electromagnetic induction. Yeah. Continue. Continue. Yes? Okay. Right. So you have two types of transformers. You have a step-up transformer. What do you think happens to the voltage in a step-up transformer? Yeah, go on. Yeah. It increases the voltage. Have a guess what a step-down transformer does? Decrease the voltage. Okay. Please write these words down. Yeah. Oh, you need to go? Yeah. You have an appointment, is it? Or?
Yes, actually.
Okay. Oh wait, are you going to come back?
Yes,
Oh, you're going to leave your stuff then? Okay, yeah.
30 minutes.
Yeah, that's fine, okay. Okay, continue. You got that? Right. We already talked about how it works, so that's good. And we have our formula. That's good. Now, this only works if it is 100% efficient. But of course, what happens is in real life, this actually gets a little bit hot. Now, it's not so bad. You know, nowadays, if you put your hand on this, it doesn't really feel hot.
What?
This.
You don't feel hot?
No, just like a little bit. But no, trust me. When I was a kid, you know, if you had an old Atari. Atari, you know, for the old video games.
Yeah.
What is it? ATARI 2600. Very.
It's my childhood.
Huh?
It's my childhood. I think.
Really?
Yeah.
No, because I played this in maybe around about like 1989, maybe 1990.
It's red and white.
I don't remember. Because the games are very old.
Yeah.
Very old. You know, like.
The tank. Pew, pew, pew.
Yeah, like this, yeah. So anyways, what I was saying is, if you had the transformer for that, I remember as a kid, it would get very, very hot. Very, very, very hot. Nowadays, they're made very well. They don't get so hot, you know. So I would say, I don't know, maybe it's like nowadays 90% efficient.
90%.
Yeah, because it's not so hot. You know? But I feel like the ones I had as a kid maybe were like, I don't know, 20%, you know, because they would get so hot. Okay. Now, if it's 100% efficient, what you can say is the power in should equal the power out. If it's 100% efficient. Therefore, okay, so let's look at what happens here. You have V1 over V2 equals N1 over N2. Okay? You also have P1 equals P2, which means I1 V1 equals I2 V2, which means I1 over I2 equals V2 over V1. Okay? But if you look at this, that's going to equal N2 over N1. So you can also make this formula N1 over N2 equals I2 over I1. But remember, that's only if it's 100% efficient. Okay, because you need this to make this Yeah. It's okay, Ben? No, well, maybe I have the formula here. Yeah, you go. What's wrong, Ben? Yeah. What's wrong with you guys today? You look so tired. And what's wrong with you? What did Neil do with you?
It's not me.
Well, what did you do in EAP support that made you so tired?
Oh, Neil says he's so boring.
Neil is so boring. Oh.
He talked last week.
Did you at least learn some EAP?
No.
Nothing.
Nothing.
Not one thing.
Just
Yeah.
They just told us how to write the next 2 weeks listening summary.
That's a good thing.
Yeah.
It's important.
But
Yeah.
he told to Ben
Yeah.
the last week.
Ah, so Ben heard it twice.
Yeah.
Good for Ben. Why did he tell you last week? Were you the only one there last week?
They told me I missed.
Trouble.
No, I didn't saw the email.
Okay. Okay. Right. Here is an example. So, you have a small toy. It needs 6 volts. It draws its power from 220 volts. Do you know what main supply is? This is called main supply. This thing. In English, you can also call it just the mains. Yeah, and in Ireland it gives you 220 volts.
You're right on Chinese.
Huh? Chinese?
Yeah.
Is it Chinese?
Yeah.
For what?
It's hard to say.
Good or bad?
Good.
Okay, good. Right. The number of turns on the primary is 4,400. How many turns are on the secondary? Okay, I think you can do this. Give it a go. You have to use your formula. Which formula do you use? Oh, come on, go.
V1 or N1 equals V2
Yeah.
or
Now that's not called the mains. What's that called? Come here.
I mean, this
No,
this is Chinese.
that's Chinese. That's the Chinese one.
Without
Yeah. What's this called? What's this called? This part? Plug. Plug. Okay. So just a little bit of English here, right? Just to be clear. Wall. Plug. Okay, this one's called the plug. This one here? What? Okay, I'll draw it better, fine.
oh, it's nice.
Happy, Ben?
three
Your primary colors.
set number.
Summer.
Oh yeah, the left one is the E. Like this. Yeah. So what's your question?
Okay.
Ask from a second.
Yeah. So in that question, the N1 is
4,400.
solid.
Okay.
4,000.
Well, I'll let you do it in a minute. I just want to give you some vocabulary before you do it. Just 1 second, okay? So this here is called the plug. Okay? This here, this part here, is called the pin. Okay? This here is called the socket. And this here, that gives you the 220 volts, this is called the mains. Okay? Do you know all these words? You knew this word. Did you know this word, socket? No? Okay.
So which one is the socket?
This is the socket.
Yeah. So you just said the main.
The mains is the energy
Yeah.
that comes out of it. That's amazing, Ben.
It's 3 pin.
3 pin, yeah. And these 3 have a name. Do you know their names?
Hole.
No, in English.
Ground.
Earth or ground, yeah. Earth or ground. This one?
0.
Live. And this one?
Fire.
Fire?
Fire.
No. Neutral.
Oh.
Why name is like this? Earth.
It's different.
But the live is but the oh sorry the neutral
Yeah.
in our language is the fire line.
Fire?
Fire line. Hole.
Interesting.
Yeah.
Okay.
It's positive.
No, the live is the dangerous one.
Oh.
Look, show me your plug.
Wait.
See? L,
Oh.
N, and
O
E.
is opposite.
Well, yeah, because it goes into the wall. So look. This one here, safe.
Ah.
Little dangerous. Very dangerous. So if I could take this and, you know,
Oh.
this is fine. Okay? That's fine. Not fine.
Okay.
Don't put them in here. You can put them in here, that's okay. Not in here. Alright?
You didn't open.
It didn't open? It should open.
No, I mean.
Oh, that! Yeah. It's fine.
Please don't. Please don't.
Now, okay. I know what I'm doing, don't worry. Alright. Try this one. Try this one.
Power F. What? It draws its power.
Yeah, that means it takes its power. Okay. More English. Okay.
Oh.
No, this is good, Ben. This is good. Draw is a verb, and it has two meanings. It can mean to make a picture, or it can mean take.
Oh.
What? You can draw this pen.
No. You only use it when you talk about taking power
Oh.
or taking money.
Oh. Oh. Okay.
Yeah. So you can draw money, you can draw power,
I can draw.
and you can draw.
BA. The B and the area. Turn the area is.
Okay. Have you got this calculated?
120.
You got 120?
I don't know.
You don't know? Calculate.
I need.
Did you get an answer, Gal? No. Why not? What's the problem? So you say 6 over 220.
Why?
Oh, sorry. 220 over 6 equals 4,400 over N2. So N2 is, you said 120.
But it's hard. If you put the 220 over the 4,400,
Yeah.
it's the 20 times.
Oh yeah. I can see, and you can cancel this. Yeah. What's wrong?
Huh?
It's okay.
Oh, what is 6?
Here. The toy.
Well, it's 6 volts.
Yeah, so look. Oh, you're very confused. I thought this was an easy lesson. Sorry. So here you have 220 volts,
Oh.
okay? But you need 6 volts,
Oh.
okay? This comes from a mains, and this is to go for a toy.
Mm.
Do you understand? This is okay. Are you sure? Ben?
But
Yeah.
where is what is primary from secondary?
Primary is this side, secondary is this side.
So it's N.
Yeah,
One N.
yeah.
Okay. Oh.
Yeah?
I don't know what is primary.
Well, we had it in the picture earlier, didn't we?
Yeah, what's this meaning? Primary core.
Yeah.
Primary is a little.
Primary
The
school,
first
secondary
one.
school.
Yeah, yes, primary, secondary. V1, V2, first, second.
Soil. What's soil?
What's what?
COIL.
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 Oh. Okay. That's a coil.
Okay.
Yeah?
Yeah.
Now you see, I told you this, and you'll forget it unless you write it down. So you can try to remember it. So write down the new word you learnt. Because you know what will happen? In 3 weeks you'll say, teacher, what's a coil? Yeah, right?
Really?
Yes, you will forget this.
Oh,
I
I remembered in the.
Yeah, tell me, Summer, what's this called? Do you remember what this called? Do you remember?
Pendulum.
Oh, pendulum.
Right. Just one example. Easy lesson. Well, I thought it was easy. No, we have 2 hours. Don't we? Yeah. So, try these for a few minutes and we'll start the next lesson. That's so sad.